My name is Dr.S.Venkata Mohan. I am working as senior scientist in Indian Institute of Chemical Technology. As you all know that Indian Institute of Chemical Technology is a premier institute for basic and applied research in organic chemistry as well as other chemical engineering aspects. Our department, Bioengineering and Environment Center, is working in various areas of environment and energy. And at present consumption rates, the fossil fuel reserves, which are main source for energy, will not be there for another 30 years. Everything get exhausted. So there is urgent need for alternative energies. Alternative energies means bioenergy. People now are looking into bioenergy as an alternative source because which is sustainable. So my major focus is wastewater treatment, and wastewater treatment as a whole, when you see it, it is not a waste. It contains a lot of organic matter, which is a substrate for bacteria. Bacteria needs to survive on an organic source. So the basic concept in biological wastewater treatment is the wastewater with organic source is given as a feed for bacteria, which take organic source, which is nothing but a pollutant, and treatment will happen. This is the basic concept of biological treatment. But we try to reorient the wastewater treatment. Like why can't we use wastewater as a value addition source for some bioenergy or some other products? In this direction, initially we try to manipulate, regulate the anaerobic metabolism, which is producing methane, which is again a greenhouse gas. We try to regulate it at estrogenic phase and generate hydrogen, which is a green fuel and a future energy gas. This we tried since 2003. We started working on it, and we tried with various wastewater, and we are able to produce hydrogen. And in the meantime, in 2006, we thought, why we have to store hydrogen and again we have to transport it. Why can't we directly extract energy from waste? In this direction, we tried to develop microbial fuel cells, which is very similar to anaerobic treatment process, where hydrogen and methane is produced. We just introduced electrodes into the system, and these electrodes capture the bacteria, releases electrons and protons that can be captured, and it can form as electricity by a defined fuel cell system, which we can see in our laboratory. Extensively working on microbial fuel systems. Recently we got a project. The basic theme of this project is to evaluate the biomass, additional excess biomass which is available in India, in order to find the potential amount of these things used for bioenergy generation. We try to get the data, basic data, availability data of excess biomass from various agriculture and industrial and domestic sources, and try to formulate a strategic research agenda in how to go about in future for generating of biofuels from this excess biomass. Excess biomass means when we take agriculture biomass, it is also biomass, but it has additional usage, like it can be used as a cattle feed, and it can be used for some other purpose. And our basic objective is to find out the biomass which doesn't have any usage. That biomass can be used for biofuel generation. And during our course of research, recently, since 2009, we started working on algal biofuels. Like everybody know that now algal biodiesel is coming in a large way. The main advantage of this algal biomass is its rapid growth. Like when we see jethropa oil, it needs about 3 to 6 months of period for growth, but algae we can grow within 15 to 20 days. And one more advantage is it can take carbon dioxide, which is in atmosphere, as a substrate for its biomass growth, and as well as carbon present in wastewater. So both autotrophically, heterotrophically or mixotrophically we can generate biomass, and from biomass accumulated carbohydrates or starch we can convert into biodiesel. This is coming up in a large way, and India is moving in this direction to make the process viable. We started, our major focus is again of using wastewater as a substrate and mixotrophic heterotrophic cultivation. This also we can see in our lab how we are going about it. And I would like to say that our research, which we are doing for past 15 years, I can say that waste which is available all around us is not a waste. It has a definite value. We have to make it value addition, either in the form of energy or a fertilizer or a fuel or in bioplastics, which we can also see in our lab. And for an example, I will tell example. When we take a distillery wastewater has huge amount of COD. About one distillery unit can produce about 350 kiloliters a day of wastewater. It contains 1,50,000 kg of COD, which is a measure for carbon source, organic carbon source. And by using this with acidogenic process, we can produce about 550 kg of hydrogen per day from unit. So when we use microbial fuel cells, we can generate about 140 milliwatts hour of power. This will give additional revenue for an industry or an ETP operator about 2 lakhs, 1.5 lakhs to 2 lakhs per day, which is an additional revenue. And again, he is treating his wastewater. The same simultaneously is trying to produce energy, which is clean energy, and which upon combustion will not produce CO2 and there is no greenhouse gases. So we are getting dual benefit. This shows the potential of wastewater. If we can use in a sustainable way, we can generate energy, we can reduce pollution load on environment, and it's very renewable in nature. My whole concept on waste to energy or valorization of energy has a significant impact on environment, and as well as it's a significant influence on a future research as well as future environment. Now everybody is talking about energy. Energy, there are basically two forms of energy. One is renewable and one is non-renewable. At present, most of our energy needs are coming from non-renewable sources such as coal or petroleum products. And renewable means we have a lot of resources in and around us for generating of renewable energy, bioenergy. Bioenergy is nothing but energy generated from biological process or biological sources. When we talk about biological sources, the waste materials like agriculture waste or cattle waste or wastewater from our houses, domestic waste, can be used as a source to generate energy. Energy may be in the form of methane or hydrogen or electricity, or it can be and after anaerobic digestion we can also get fertilizer which can be used for agriculture. And we can also use this is the traditional methods, and when we go for advanced methods, we can also generate energy by using biomass like ethanol or butanol. By converting biomass into simpler forms and then given to bacteria, it generates ethanol and bacteria. And here I would like to say that all these processes, everything was mimicked by nature. Like everything, children are very intelligent and they have a very innovative thinking compared to our generation. Your generation was very active, so you have a wide potential. You observe the nature, and you all can each and every experiment which we are conducting in the laboratory, this is a mimicking of nature. When we, for example, I will tell that when we are using wastewater for treatment, it is nothing but a process which is occurring every day in and around your house. Like when we take milk and curd formation, it's nothing but a biological process where some bacteria is fermenting the milk to form into curd. Like that, biological wastewater treatment or bioenergy generation is nothing but a process which is already happening in and around you. So you children can pick up your good projects with respect to energy for your National Children's Science Congress. You can think innovatively, like when you want to develop a process, you can take a waste which is found in and around your school or in our house, and try to think in what way it can be made into value addition, either into form of energy or in a form of some useful product. You people can think very innovatively, and you have a intellectual ability to think in a different direction which is required for science nowadays. The ideas which came from you children will be very specific, and I found it very innovative, which can be matured upon in the laboratories. So I would like to say the children, when you are going for these NCSC competitions, you try to mimic the nature for developing a project which is your own and which is again innovative, and so that you can give important inputs for the science and research in our country. And you can do that. I definitely say that you have that potential, you will definitely do it, and I wish you all the best.